Hi, this is the Upper Key Stage 2 maths presentation, which gives you some information about what the children are expected to know and also some top tips so you can help them at home as well.
Maths in Upper Key Stage 2, top tips and information for parents. This video will focus on arithmetic skills. Why? Because arithmetic plays a huge role in Upper Key Stage 2 maths. Arithmetic skills are used by adults and children throughout their daily lives, not just in maths tests. Developing conceptual understanding of arithmetic saves time on calculations. Confidence in arithmetic gives pupils the flexibility to tackle problems in different ways. In Key Stage 2 SATs, children have an arithmetic paper worth 40 marks. And in SATs, children have 2 reasoning papers, each worth 35 marks. These contain questions involving all areas of maths, including fractions, percentages, ratio, measures, and statistics. These require sound arithmetic skills. How to improve a child's arithmetic skills? Children need to understand the reasoning behind even the most basic math skills, rather than just learning the tricks. For example, we do not add a 0 when multiplying by 10, because this does not work for decimals. 1.57 multiplied by 10 is 15.7, not 1.570. Instead, we use place value charts to show them that the digits move. The decimal point always stays in the same place. Here's an example of a place value chart. 1.57 is listed first, and then we've moved all the digits one place to the left, but the decimal point has stayed in the same place, so 15.7 is the answer. Teachers use concrete and visual resources in lessons to support their teaching and to help the children understand the why. For example, to find fractions of numbers, we show them bar models to support their understanding. In the question, find 3/4 of 36, we have a bar, so the whole bar represents 36. We split the bar up into 4 equal parts, and these each represent 1/4. So 3/4 is shaded because it's 3 out of 4. That means that each part is worth 9. And because we want 3 out of 4 parts, we do 9 times 3, or 9 plus 9 plus 9. Therefore, 3/4 of 36 equals 27. Arithmetic tests. In the Key Stage 2 SATs, there are 36 questions in the arithmetic test, totalling 40 marks. Children have just 30 minutes to answer all those questions, and in that time, they also need to have checked their answers. So, let's have a look at a test. This is one of the official arithmetic papers from the SATs. We're going to have a look through it, look at the questions that would require just mental calculations and those that would require a more formal method. 6,000 plus 90. The children need to know the value of each digit. They need to know that the 6 is worth 6,000s and that the 9 is worth 9 tens. So when adding them together, they just put the 9 in the tens column of the 6,000, so it's 6,090. Question 2 requires a formal method to be accurate. Let's have a look at the column method for addition. So the question is 8,275 plus 82. We need to make sure that the 8 is lined up with the other tens and that the 2 is lined up with the other ones. So 8,275 plus 82, the children need to add the ones together first. 5 plus 2 is 7. The tens, we've got 7 tens plus 8 tens, which makes 15 tens. 200s plus 100 is 300s. And then 8,000s plus no thousands is 8,000s. and that would give the children 1 mark. Question 3 would require mental calculations. 800 plus something plus 6 equals 826. It's just looking for the value of this digit, and this 2 is worth 20. So the children write 20. For question 4, the square, the missing number, is at the beginning of the calculation, which means that the children have got to do the inverse operation to get the answer. So 341 subtract 5 gives us the answer, and it's 336. And then they check by reading it and making sure it makes sense. Question 5, 9 times 41. The children would be required to do the method for this, and there's a few different methods that they can use to be successful. The question said 9 times 41, but 41 times 9 makes it much clearer. The children can do the short multiplication method, which looks like this, and they multiply each of these top digits by this number, by the 9. So 1 times 9 is 9, 4 times 9 is 36, it's actually obviously 40 times 9, which is 360, and then it's 369 as the answer. They can use the partitioning method, so 41 is made up of 40 and 1, and they multiply the 40 by 9 and then the 1 by 9. 4 times 9 is 36, so 40 times 9 is 360, the 1 times 9 is 9, and they add them together and get 369. The third method they could use is the grid method, and they partition the 41 at the top, they put the 9 on the side, and then here they do 40 times 9, which is 360. Here they do 1 times 9, which is 9, and they add them together to get 369. As long as they get the right number, it doesn't matter how they got there. The next question requires the children to add together 2 decimal numbers. As you can see, the first number has 2 decimal places, and the second number has 3 decimal places. This is what the children would be expected to do. So use the column method to add the 2 numbers together. Make sure everything's lined up. So the ones are together, the decimal point is together, the tenths are together, the hundredths are together, and then 5.87 hasn't got any thousandths, but 3.123 has. So the children should draw a 0 as a placeholder to give both numbers the same number of decimal places. Then they start with the thousandths. 0 plus 3 is 3. The hundredths, 7 plus 2 is 9. And the tenths, 8 plus 1 is 9. Put the decimal point in, and then add the 5 and 3 ones, which makes 8 ones. We've now got a few calculations coming up that involves some mental arithmetic. In this first one, the children need to use their knowledge of the 3 times table to answer this question. 3 times 6 is 18, therefore 3 times 60 is 180. For number 8, they need to know that 12 times 10 is 120, so the answer is 10. So times tables are so important. Here it's about whether they know that if you times a number by 0, the answer will just be 0. Number 10, the number is getting bigger, but they might still be able to do it in their head. So if they know that 7 times 10 is 70, and 3 times 7 is 21, that the answer will be 13. If they're not confident with that, they can use the bus stop method or the short division method. I'll show you that now. So 91 divided by 7 using the short multiplication method. 9 divided by 7 is 1 and 2 left over, because 1 times 7 is 7. 21 divided by 7 is 3. So the answer is 13. The children could also list their 7 times table until they got to 91, but as you can see it would take a really long time and they've only got 30 minutes to answer all the questions. For the next couple of questions, they could do it in their head. 87 take away 65. What do you add to 65 to get to 87? And then for number 12, they could use the column subtraction method like they could for number 11. It's about recognising that the two numbers are very close together, so what do you add to 594 to get to 602? It's just 8. Number 13, they could use the short division method again, or they could use their knowledge of the 11 times table. It's another really key indicator that times tables are so important. They might recognise that 11 times 11 is 121, therefore 10 times more than that would give them 1210. Therefore, 11 times 110 is 1210. Number 14, they've got to multiply by 10, and whenever we multiply by 10 we say move all the digits one place to the left. If it's multiplying, it's to the left. If it's got 1 0 in the number, it's one place. They haven't got a place value chart in front of them in a test, so they need to know the place value of everything really, really carefully. They could draw their own place value chart, or they could just think, well, that 2 is worth 2 tens. If I'm multiplying by 10, I'm moving it one place to the left, so that 2 tens will become 2 hundreds. Then everything will follow across. 5 ones will become 5 tens, 3 tenths will become 3 ones, the decimal point will stay the same, the 400ths will become 4 tenths. The children in Year 5 and 6 get to learn about brackets, and we use something called BIDMAS, and BIDMAS tells us the order of operations. Here they would do the brackets first, so it's 30 take away 24, which is 6, then they'd do 60 divided by the 6. For question 16, that little 3 is 3 cubed, and cubed means times it by itself and times it by itself again. So it means 3 times 3 times 3. If it was 7 cubed, it would be 7 times 7 times 7. Here we've got 101 multiplied by 1,000. So it's multiplied, which means you move everything to the left. And because 1,000 has got 3 zeros in it, we move it 3 places to the left. So everything will move 3 places. So if you're looking at the 100, you think, well, what's 3 places higher than that? So after 100, it's thousands, then tens of thousands, then hundreds of thousands. So that will be in the hundreds of thousands position, and everything else will follow. And you'll need zeros as placeholders to fill in the gaps. For percentages, children need to use their knowledge of fractions, decimals, and percentage equivalents. By Year 6, they'll know that 20% represents 1/5. So to find 1/5 of a number, you will divide the 3,000 by 5. And they could draw themselves a little bar model, split the 3,000 into 5 sections, and do 3,000 divided by 5 using the short division method. They could know that 5 lots of 6 are 30, and therefore 5 lots of 600 are 3,000. Let's have a look at number 19 on the notebook. 7 take away 2.25. If I line everything up so that the ones are together, it looks like this, which makes it really, really difficult to calculate. Therefore, we put a decimal point in and give everything the same number of decimal places again to make it much easier. So now we can do 7 take away 2.25. 0 take away 5 is not possible on here, so we've got to go to here to exchange, but there's nothing there, so we've got to go right back here write a 6, put the 1 there, but we still need 1 here. I'm going to cross out that 10, put a 9, and exchange again. So I've got 10 take away 5, which is 5, 9 take away 2, which is 7, 6 take away 2 is 4. So it's 4.75. Another method, which takes longer to do, is to put the smaller number on the left and put the bigger number on the right, and then add up until you get to 7. You could think, what do I add to 2.25 to get to 3? So I add 0.75. Sometimes it's helpful if they give everything the same number of decimal places again, and think of it as money. So £2.25 plus 75p gives me £3, plus 4 whole ones gives me the £7. So the answer is 4.75 by adding these two numbers together. So just to speed everything up a little bit, I've whizzed through the test to look for a question that I need to explain. 836 multiplied by 27 is the one that the children are required to do. For this question, it's worth 2 marks. So there's 36 questions, 40 marks altogether, which means there's normally perhaps 2 long multiplication questions and 2 long division questions. This is one of the long multiplication questions. What they've got to do is 836 multiplied by the 7, and then 836 multiplied by the 20. And this is one of the ones that they struggle with. So we're going to ignore the 2 for now, and we're going to do 836 multiplied by 7. 6 times 7 is 42. Just like before, we would do this. 7 times the 3 is 21, plus the 4 is 25. 7 times 8 is 56, plus the 2 is 58. So because this 2 is in the tens column and not in the ones column, we put a 0 here because everything needs to be 10 times bigger than just this 2. 2 times 6 is 12. 2 times 3 is 6, plus the 1 is 7. 2 times 8 is 16. And then we draw our lines, which represent the equals, and we add these together. 2 plus 0 is 2, 5 plus 2 is 7, 8 plus 7 is 15, 5 plus 6 is 11, plus 1 is 12, 1 plus 1 is 2. So the answer is 22,572. If they really can't grasp that method, then if they get the right answer, they will still get 2 marks. To have a go at a method, to have a go at this method, if they get this right or this right, then they will get 1 mark. So sometimes it is better to just learn the right method. So I've partitioned 836 into 836, and I'm going to partition 27 to 20 and 7. I've got to multiply everything together now. So 8 times 2 is 16, and we're going to multiply that by 1,000. 2 times 3 is 6, multiplied by 100. 2 times 6 is 12, multiplied by the 10. 800 times 7, so 8 times 7 is 56. We need to multiply that by 100, so we add these on. 7 times 3 is 21. Needs to be 10 times bigger. And then 6 times 7 is 42. Then the children can add these 6 numbers up with the column addition, and they will get 22,572. This is another calculation that the children need to know the answer to. This is a question that involves the need for long division. because the number that we are dividing by is greater than 12. So it's 888 divided by 37. They need to know how many 37s are in 8, so 8 divided by 37, which we can't do. How many 37s are in 88? Well, 37 add 37 is 74. Therefore, 2 lots of 37 go into 88. What we do here is we write down the answers to our multiplication facts underneath to keep a running record of our calculations because the numbers are bigger. It's a lot more to keep in our head otherwise. So 2 times 37 is 74. I write the 74 under the 88 and I do a subtraction. So 88 take away 74 is 14, so that's my remainder. Now it's how many 37s go into 14, or 14 divided by 37. And I can't do that because 14 is not big enough. So I bring my 8 down and we say, how many 37s go into 148? Or what's 148 divided by 37? I can keep listing my 37 times table, or I could do some short multiplication to quickly work out some facts. 7 times 4 is 28, 3 times 4 is 12, add 2 is 14. I could see that if 2 lots were 74, 148 was twice as big as that, so it was 4 lots of 37. So 148 divided by 37 equals 4. And the answer is 24. That would give you 2 marks. If you can't do that method, but you get 24 as an answer, then you still get 2 marks. But if you go wrong in one place on here, you might still get 1 mark if you get the wrong answer, which is why it's worth learning the actual method. If you try it with the normal short division method, you can still get the right answer. So 8 divided by 37 you can't do. 88, so we carry the 8 along. 88 divided by 37 is 2, because that made 74, so the remainder was 14, and we squash it all up. 148 divided by 37 was 4.
There's so much other content in the arithmetic test, but I won't go into that now. If you'd like to know how to add, subtract, multiply and divide with fractions, then just send me an observation on your child's tapestry and I'll do another video explaining those.
So just before we go, we're going to have a few top tips about how to not lose silly marks in the arithmetic test. Firstly, the children need to make sure that the answer that they write down in their calculation is exactly the same as what they've written in the answer box. You'll be surprised at how many children have lost marks from not copying correctly. Ensure the correct operation has been used, so if the question says addition, make sure they haven't done a subtraction calculation. Again, you'll be surprised at how many children have done the wrong one. If there is time, the children should recalculate some of their answers. They could use the inverse operation. So for example, if it's a division calculation, they could use multiplication to check, and if they have been asked to do a subtraction calculation, they could check their answer with an addition calculation. They should also make sure that if they need a decimal point in their answer, that they've remembered to put it down. And a really important one, make sure digits have been formed correctly. If they are not clear, they will probably be marked wrong. I'm going to show you quickly how the children should be forming their digits. So for each digit, the children should always start at the top. 1, 2, 3, 4, 5, 6, 7, 8, 9, and then a 0. It would be interesting if you could ask your child to write down their digits and just see if they're forming them correctly. So many children do a 9 like this, and it can sometimes look like a 4, and if it's not clear, it will be marked wrong. And that's the end of the maths PowerPoint. I really hope you found something useful in the video, and please, if you've got time, take a few minutes to complete our feedback form. The link is written in the details of the video. Bye!